Hello, welcome to OCC Math Seminar video. Today's section, we're going to talk about continuity. Definition. The function f is continuous at x equals c, where c is just arbitrary point on the x-axis. If f is defined at x equals c, that means when you plug in c for the function, you should have a value, you should have a y value, right? And if limit as x approaches c of f of x equal f of c. So here we have two pieces that we need to show if f is continuous, right? It had to be defined at c, and make it bigger. Defined at c, and the limit as x approaches c of f of x, both sides, is equal to the value f of c. Right? So for example, if I have, say I have a function looking like this, and here will be my point c and f of c. So that's right there, c and f of c. So the first p is this function, it is indeed defined at c, right? So say I say c is 1, when I plug in 1 into the function, I have a height, right? So it is defined at c. Now, the limit as x approaches c from both sides. So say approaches from the left here of c and approaches from the right of c, it should also be equal to f of c. Then f is continuous. Okay. The second thing is that the function is continuous on the interval ab if it's only continuous at every point on the interval. So let's take a look at this problem. This problem is very much confirmed or try to use a definition to solve. I have a function f of x equal 1 over x squared minus 1. Find the values where the function is discontinuous. Remember, in order to, so apparently there's some discontinuity here going on here, right? If you don't know anything about calculus, if I ask you, can you find a value where the function is undefined? And then you can tell me that because this is a rational function, the points that is make the function is undefined is where the denominator is equal to 0, right? So if you solve for this, you plug in, you do x squared minus 1 equal x plus 1 or x minus 1, and then you set it equal to 0. And then either x equal to positive 1 or negative 1, right? Or and then you say it cannot be equal to positive 1 or negative 1, because at those 2 points the function is undefined, right? And it's true and it's true for this problem. Let's take a look at this graph right there. At negative 1, can the function be defined at negative 1? No, right? At negative 1, we don't have a finite value for the function, right? It looks like it's kind of jump, right? Either go up or go down, right? Same thing with 1, right? There's a jump, right? Now, so that's the first P is failed, and then you can stop. But let's talk about the second piece. The limit as x approaches negative 1 from the left and from the right is also does not exist, right? So if f approaches negative 1 from the left, it looks like I'm going to positive infinity, right? If f approaches negative 1 from the right, it looks like I'm shooting down to negative infinity, right? So there are two different limits. So we don't have the limit does not exist. But because the first part is fail, so that will be suffice. Is f of x continuous on interval 0, 2? Now there's infinitely many points between 0 and 2. But in order that if f of x is continuous on interval 0, 2, then by that definition, it had to continuous at every every point in the interval. Right? So here I have from 0 and 2, but between 0 and 2, there's a 1, and we know that is discontinuous as 1, right? So it's kind of ruling the whole thing. Right? So since f of x is discontinuous, continuous at 1, and 1 is inside the interval 0, 2, therefore, the 3 dot mean therefore, f of x is not continuous on the interval 0, 2. All right, number 2, given f of x, this is the piecewise function. I have is equal to 1 if x is greater or equal to 0, and is equal to -1 if it less than 0. So it looks like this. So if 1 is just the horizontal line, right? Y equal 1. It is included 0, so I'm going to put a solid dot here. And down here is equal -1 if it less than 0. It's not include 0, so I'm going to put a hollow dot. Is f continuous at x equals 0? Right there, 0, right? Its function is defined at 0. Let's see. When x equals 0, what's f of 0 equal? F of 0 equal 1. So it is defined at 0, right? Let's see. If it satisfies the second piece, which is limit at as x approaches 0 from both sides of f of x, it is indeed equal to f of c, or in this case, f of 0 or 1, right? All right, so we need to check if limit at x approaches 0 from the left of f of x, what is it equal to? If f approaches 0 from the left, like that, then it looks like the limit is go to -1, right? The limit is -1. If f approaches 0 from the right side, going like that, what do you see? It's equal 1. Right? So the two limits is not equal. So that's therefore limit as x approaches 0 from both sides of f of x does not exist. Right? They have to be equal in order to have a limit. They're not equal. Let's evaluate some limit. I want to evaluate limit as x approaches 9 from the left of square root of x minus 3 over x minus 9. The first thing I do is I plug it in. By the way, that's not -9, right? That's 9 from the left. So something like 8.9999999 forever, right? So I'm going to plug it in. 9 for x. So square root of 9 minus 3 is 3 minus 3, which is 0, right? Over 9 minus 9, which is 0. So this is indeterminate form. Later in calculus 2, you're going to see that this is called indeterminate form. Anyway, you have 0 in the bottom. That's not a good news. So that means you need some more work. And it may work out, it may not. Right, so let's see. Limit as x approaches 9 from the left. The top, nothing I can do, right? But the denominator, I can expand it more. X minus 9 is the same thing as square root of x squared minus 3 squared. By the way, you're going to keep rewriting the limit. I know it's just, it feel like redundant, but it's necessary. Square root of x minus 3 over, if it's different to square, so square root of x minus 3 times square root of x plus 3. And then you can cancel that with that, right? So now I have limit as x approaches 9 from the left of 1 over square root of x plus 3. Now I'm going to plug it in to see. I'm going to plug in 9, see what happened. So limit as x approaches 9 from the left of 1 over square root of 9 plus 3. Square root of 9 is 3, 3 plus 3 is 6, so 1 over 6. And that'll be your final answer. You want to pause the for a few seconds to do the second one on your own. Right. Now this one, same thing. The first thing I do, I'm gonna plug it in to see what happened. When I plug in -5, I have 0 on the top, and I have 0 on the denominator as well. So maybe we need some more work. Right. Limit as x approaches -5. Just this time is a -5, not from the left or from the right. It's only from both sides of -5. X plus 5 is nothing I can do, but on the denominator, I can factor that, right? So it'll be x plus 5 times x minus 5. Then I can cancel the x plus 5 and x plus 5. So I have limit as x approaches -5 of 1 over x minus 5. Plug in -5 now, right? It's 1 over -10. By the way, you can kind of check it with your graph to see where your graph go, right? We can check it with the graph. Let's see, take a look at the graph. I'm going to mute that one. Then turn on that one. Right. So -5, so here the function right here. So right there, I don't know what the point right there is. -0.02, but it's gonna go a little closer and closer to the x-axis, right? So it's when you go to -5, if I approach is -5 from the left and from the right, where does it go? Let's see if I can. Right. Well, at -5, of course, it's kind of difficult. At -5, of course, undefined, right? But if approach it from the right is 0.1, -0.1, which is roughly -1 over 10, right? And then to the left, same thing, right? -0.09999 something, right? So it proved that you got the right answer. Right? Thank you for watching, and see you next time.